Hello, my name's Jose Arevalo, and I'm a global business development manager with DuPont, and here to talk to you about something that we kind of talked a little bit about during the Science of Sealing seminar that we did here last year, which we'll do again, I think, for some more folks to kind of bring you up to date. But we were talking a lot about peel strength, and we were talking about the variability in peel strength and the testing and everything else associated because of the deformation that can occur when you open a pouch in direct seal applications. There are two exceptions where that deformation does not occur, and that's in a coated product and also in a cohesive peel. So over the last few months, I became aware of some new work being done on the cohesive front, and today we have someone here that's going to talk a little bit more about that and help you understand how a cohesive system can help with the variability in peel strength, and we're going to talk a little bit about the technology behind that and how that can help you if you really need to have that variability eliminated from your process. So we're going to talk a little bit about cohesive systems, and with that I'd like to welcome Doug from PAXXUS to talk a little bit more about the details of that. So Doug, could you join us here on video? Welcome. How are you, sir?
I'm doing fantastic. How about you?
I am doing great. So tell us a little bit more about this cohesive technology that you've developed and how that can be kind of a game changer here for the industry.
Perfect. Well, for those of you who haven't met me, I'm Doug Dodrill. I am the Chief Technology Officer at PAXXUS, and I deal primarily with technical support as well as product development. So one of the big projects that we've been working on quite extensively is cohesive peels, specifically for use with Tyvek. So yeah, I'm looking forward to sharing a little bit of what we've done in the last few years. So,
perfect. That sounds like a lot of work that you put into it. And we know that cohesive technology has a lot of advantages, right, to the adhesive systems or some other systems. But, before we get into that, can you talk a little bit more about the technology behind cohesive systems and how they work so that the audience can really understand that?
Yep, that's probably a logical place to start. So we can talk a little bit about the mechanics of the different peel mechanisms. So I think most people are familiar with polyester polyethylene seals to uncoated, which would fall in the adhesive peel category. If we could pull up the animation and take a look at the adhesive peel mechanism, the light green line represents the film sealant, and the gray area represents the substrate to which it is sealed. In this case, it would be the Tyvek. So as the film is peeling, it actually just leaves both surfaces pretty much in the exact same state that they were in before they were sealed once they're separated. So there's no transfer of any molecules whatsoever between the surfaces. It's strictly just separating and leaving the two. It's sort of almost analogous to if you have something like Scotch tape and peel it off of a surface. After it's peeled, you still are left with the two original surfaces.
Right, and we talked a bit about that in the Science of Sealing webinar that I did a couple times last year, which I promise everyone will do again this year. And in that process of pulling those two substrates apart, there was deformation that was occurring in the film side of things that were adding to the variability of that. So just to kind of tie it into the Science of Sealing that we did, but go ahead, Doug.
Right. So I was going to show, I have a traditional polyester polyethylene sealed to uncoated Tyvek here. And when you peel that open, you can see, and hopefully this shows up on the camera here, you can see that the surface does get roughened up a little bit, and that's just a mechanical roughening from the heat seal process. But other than the texture being changed, it really is left exactly as it was to start with. It's still just the polyethylene surface there. So we can contrast that to a cohesive peel. So if we play that animation, now you can see that that same light green surface, as it's peeling away from the Tyvek, is actually splitting in the middle of that layer. And basically it's sacrificing the skin layer and transferring the skin over to the Tyvek surface. So the mechanism is different. Rather than actually peeling cleanly, it's transferring the surface over to the Tyvek.
So I think for clarity's sake, if I could jump in, Doug, so what we're trying to say is that the portion that touches the Tyvek permanently seals to the Tyvek and adheres to the Tyvek, and we're having a fracturing occurring within one of the layers inside. So we leave part of the film attached to the Tyvek where it's sealed, and then it fractures through the center somewhere so that it splits apart.
Right, exactly. That surface never separates from the Tyvek again. The splitting occurs a layer up within the film itself, leaving that skin layer that's in contact with the Tyvek behind.
Perfect. There we go.
So here we have a cohesive peeling film that as you peel it away
up higher. There we go. Thank you. There we go.
Thank you. Away from the Tyvek, you can actually see that the skin layer, which is tinted with the green pigment in this case, is actually transferring over to the surface of the Tyvek.
Right, so the pigment is built into the film, and as you transfer over, it shows up and you can see it readily on the other side when it's permanently attached to the Tyvek side.
Right, exactly.
Perfect. So Doug, so let's talk a little bit more now about what's going on in the cohesive layer, and how does that work?
Yeah, well, the main principle behind creating a cohesive film is taking a polymer and adding some additional incompatible polymer in the matrix to disrupt
some ingredient that you put in there.
Right. There's a second ingredient, or sometimes even a third ingredient, that's used to disrupt the polymer matrix. And that weakening of the polymer matrix is actually what creates that cohesive peel. So there's several different chemistries that can be used. Polybutene would be a common one, but there's many other combinations of incompatible polymers that will create that same effect.
And perfect. So then that additive that you put in there creates a weak point in that film structure, so that when you go to open it, it will actually break along that weak point that you've kind of designed into that film layer. Is that correct?
Right, exactly. You want the bonds within the sealant layer itself, within the polymer matrix, to be weaker than the adhesive seal bonds. So rather than just separating away from the Tyvek, it actually splits and leaves the polymer behind.
Perfect. So you leave a layer on the Tyvek, and then the rest of it goes with the film, and then you put a colorant in there, and then that gives you an ability to actually see a nice transfer occurring against the white background of the Tyvek.
Right. There's a whole bunch of factors that can control how the cohesive peel is going to behave and what sort of strength you accomplish. The most obvious of those is the choice of chemistries that you're mixing together, as well as the percentages of the secondary polymer that you're adding into the matrix. But it gets a little bit more complicated than just those two factors. You also have to look at the viscosities of each of the polymers that you're blending together. The idea is you're trying to control how those little islands of the secondary polymer are fitting into the matrix in the primary polymer. So if the viscosity or the melt index of the resins is very similar, then they tend to create a very easy and uniform dispersion, which may or may not be desirable depending on what type of seal strength you're trying to create. If there's a big disparity between the viscosities of them, then you tend to end up with sort of larger islands of the secondary polymer, which control also would increase the seal strength in that situation. It's sort of like whether you're mixing toothpaste and honey together, mixed together real easily, versus toothpaste and tar is going to be an entirely different mixture.
So excellent. So it sounds like there was a lot of work done for you to develop your version of this cohesive film then, and get something that was consistent and worked well. And so I think you alluded to something I think that's important, and in terms of the science of sealing that we talked a lot about. And in that presentation that I gave, we talked a lot about the variability associated with a straight adhesive peel, where the sealant layer is directly to the Tyvek and the sealant layer comes off the Tyvek. In this application, you're actually permanently bonding and splitting it through. So can you alter the quote unquote strength that you're receiving in terms of when you peel it apart?
Yeah, absolutely. So by altering the percentages of the two resins or three resins that you're mixing together will tailor the seal strength to what you're trying to accomplish. In this case, you want to make it light enough that you avoid having any sort of fiber tear, and you want to move the stress point away from the surface of the Tyvek back into the film surface itself, in order to get that smooth peel and avoid any sort of variation when you're peeling it from the Tyvek.
Excellent. So not to get too much into the details of your particular film and product, but what kind of seal strengths are you typically getting, let's say, on this material that you're planning on introducing?
Yeah, we're targeting about 1.5 pounds as a typical seal strength.
Perfect. And then let's say a customer came to you and they wanted something that was a little stronger. Can you dial it up or dial it down? Is that a possibility? Does it work that way or not?
It does work that way. Yeah, you can do quite a bit of tailoring in the formulation to adjust that number up or down depending exactly what you want it to.
Excellent, excellent. And so, what have you seen in terms of the consistency of that strength that you're able to develop?
Yeah, there's a real dramatic change in how consistent your seal strength results will be when you're working with a cohesive peel versus an adhesive. In fact, if you pull up, if we could show the chart comparing the seal strengths of an adhesive seal versus a cohesive seal, you can see that as the temperatures vary, the adhesive seal strength just keeps on increasing. So as you add 10 degrees to your seal temperature, the seal strength just keeps on going up, sort of in a fairly linear manner. When you get to the cohesive peel, as the seal strengths change, once you've activated that seal, it no longer changes. It's pretty much a straight line on a seal curve. No matter, you can move this temperature 10 degrees either direction, you're not going to see really any change in that seal result.
So that's kind of important to a packaging engineer or someone in the plant in terms of processing. What kind of windows are you experiencing? Let's say a processing window for this material.
Right, we're pretty much finding that once you get above about 265 degrees Fahrenheit, you've fully activated that surface to the Tyvek, and then you can go all the way up to where the limits of Tyvek. So essentially, when sealing through the film, you can get almost about 300 degrees. So you have about a 35-degree window before.
Wow, that's huge.
It depends a bit on your how long you're sealing it
right,
for.
The dwell time.
When you start transpertizing and distressing the Tyvek.
Right.
But into the film, you can get pretty hot there.
So a 30-degree window is pretty impressive. I mean, 20 degrees is great. I think that's a great processing window, but to get up to 30, that's pretty impressive. So I think that it sounds like this cohesive system is very forgiving in very difficult kind of sealing conditions.
Yep, that is the intent. Yeah.
Great. And then one thing else that I saw when you opened the pouch was the color transfer. So can you show us that color transfer that's occurring on the pouch again?
Mm-hmm.
And if you can just bring it up, yeah, there you go. And can you bring it up a little closer to the camera so folks can see that? That's incredibly consistent and I mean, very easy to see. So, I would imagine with some of the regulations that are going on in Europe in terms of, what they're requesting, that, when you open it, right, that that it's there's no issues, right? So can you talk to that a little bit about what you see this material being able to do?
One of the key elements of the new MDR in Europe is the ability to prove the integrity of the package at the time of use. And having a visual indicator, such as having a cohesive peel that's transferring on the Tyvek, is a real easy way for the nurse at the time they're opening the package to know, yes, this was sealed properly and I have a sterile package. So I think that's really going to be an easy solution to satisfying that requirement of the MDR.
Yeah, so no, I think that's great that because I noticed that transfer there when you opened the pouch, and it looked really interesting. And just on a side note, sometimes people like different colors. So is this something that you can do different colors with?
Yeah, it could be done with pretty much any color that you wanted.
Wow, that's pretty neat. So that's an interesting little twist to be able to kind of have that transfer on the other side. So I think that's kind of a different thing to be able to do. Most of the times you're locked into something. So
yeah, it could potentially be used as a branding initiative, or whatever you can come up with in your imagination is probably available.
Perfect. Well, listen, I really thank you for your time, and we're going to come back to you here in a little bit. And right now we're actually going to transfer here to one of our technical folks at DuPont. His name is Mark Sunt, and Mark has been able to actually play with this material. I shouldn't say play, because they don't really play in the technical group. He's actually been able to test it and look at it. And Mark, we don't, we see a lot of adhesive materials out there, and I think it was important for us to kind of take a look at cohesive materials. So what can you tell me? I know, during the transition protocol, we made and opened 1.1 million packages, right? So we know a little bit about opening things. So what can you tell me about this cohesive film that you saw?
Yeah, thanks for having me, Jose. Yeah, so I think, like most people in the industry, we're very familiar with adhesive type films and such, and so it was neat to have an opportunity to kind of, to use your term, play with this film that has that cohesive peelant technology in there. A few things that kind of came to mind as I had a chance to somewhat evaluate it. So one thing that, as most people would do, we tested for seal strength, and so that kind of gave us some quantitative feedback about this cohesive technology. And what we saw, that over a relatively wide range of sealing temperatures, we saw that the seal strength was, for lack of a better term, a fairly flat line. And as most people are probably familiar, at least with adhesive technology, that as you typically increase temperature and or dwell time, you typically start to see the seal strength continue to increase. And so so quantitatively, it was nice to see kind of, once you got to a certain, I'll say, threshold point, you saw the seal strength somewhat level off and stay consistent over several degrees. And in this case, I think it was maybe around 20 degrees Fahrenheit. We saw this very flat profile, if you will. So that's quantitative. From a subjective perspective, what was also nice about that was just the opening, the feeling or opening of the packages. As you went from, let's say, a lower temperature to a higher sealing temperature, the feel or the change in how it felt when you opened the package didn't change, and that would obviously make sense as we measured the seal strength staying consistent. I'll say the opening feel felt very uniform, so it was a very familiar feel, if you will. So that was I'll say one aspect of kind of the cohesive technology that was very very pleasing. The other thing that, just kind of off the top of my head as we think about cohesive, since the mechanism of that cohesive failure, if you will, is happening within a layer of the film, and you're leaving part of it on the other web surface, in this case, let's say Tyvek. I'll say the potential or the propensity for fiber tear to occur, I believe, is probably going to be less, as now you're no longer stressing the surface of, in this case, the Tyvek by, for lack of a better term, peeling or ripping off that film off of the surface of that Tyvek, but instead you're now making a break within a layer of the film itself. And so from my perspective, the stress on the surface of the Tyvek is less. And so in that case, you would expect a lower potential for fiber tear. So that,
and was that your experience, Mark? Did you have any fiber tear? Did you have minimal? What would you say?
Yeah, so as I mentioned, we had, I looked at several packages or groups of packages across a range of sealing temperatures, and across that range of sealing temperatures, we saw minimal to no fiber tear show up. So a very good performance from a fiber tear perspective. So that was nice.
So excellent. So I think an important point can be made here in terms of cohesive technology. If someone is very concerned about some level of fiber tear and they don't want to go to a coating type of product, then cohesive would make a lot of sense to use, because that film stays on the Tyvek side, and so as you open it up, and you're saying you experience minimum, or if not any at all, no fiber tear on the opening of that, then that sounds like a really good system or technology to use first to get a consistency on fiber tear, as we talked about in the science of sealing. And I think secondly, from a fiber tear perspective, as people are really, really concerned about that this might be a better way to go.
Yes, absolutely. Yep, completely agree. Fiber tear is always a concern by the end user. And I think, again, looking at the cohesive technology, since you're the way that the mechanism in which it fails, if you will, it lends itself to less of a chance of there being fiber tear showing up. So
out of curiosity, how many samples did you get to open up, or did you test in the lab?
In total, it was probably over 100 packages that we looked at, and so a fairly reasonable sample size. Not anywhere close to the 1.1 million that you referenced earlier as part of the
it was a quick look. Yes, it was a quick look that you were doing. And how many of those did you experience maybe minimal fiber tear, if any at all?
Probably maybe one or two packages. And when we're talking about fiber tear, we're talking very small, like a wisp of fiber tear is what I recall seeing.
Oh, a wisp. So it's not even like, so I would say a wisp is a pass, but I'm glad you were very thorough in looking at the surface itself. So it's just, maybe most people wouldn't even consider that a fiber tear, but there was 1, 2 that had a wisp out of 100 something. I think that's really says a lot for cohesive technology and its ability to stay pretty much as fiber free as possible. So excellent. So are there any other observations that you would say that you had with this cohesive film?
Yeah, I guess one final observation. I'm not sure that it's necessarily exclusive to cohesive technology, but the film that we did look at did have a tinted coating to it. And so subjectively, that was a nice, I'll say, option or that was available for a couple of reasons. Well, the main reason being is both before and after opening of the packages, that I'll say that change in contrast was nice to be able to see. So in kind of the pre-opening or pre-inspection of the package, you could actually look at the seal area and just verify, again, kind of having this high contrast or different contrast look to it to see is there any potential channel or non-uniformity in the seal that you're seeing. And then after opening the package and such, then being able to then go back and see that amount of, I'll say, tinted sealing material on the surface still there. Again, you could then also see the contrast difference, and again, just verify, again, get an idea of how adequate or how uniform the seal was. So that was kind of a nice feature.
Excellent. So it sounds like you had a good experience, and it sounded like the Tyvek, structure wasn't really, affected, and that this was really, the cohesive technology is really a good way to go if you're going to do a direct seal application and not use a coating and get consistent seal strengths, right?
Yes, absolutely. Yes.
And so just out of curiosity, what kind of seal strengths were you getting in the lab?
Measuring off the top of my head, we were getting around about an average of 1.5, 1.5, 1.6
Perfect.
pounds per inch.
And did you take it from various locations around the pouch itself?
Yes.
Was there
Understanding
any
that.
was there
Sorry.
any change in any location, or was it the same all the way around?
No, it was fairly uniform. Again, measurement of seal strength it has some variability, obviously, like most other measurements and such. But what we found, again, we took samples around the periphery of the package. Again, understanding that sealing equipment or package making equipment has variability in itself, as well as the seal strength measurement itself has some variability. But what we saw was, for the most part, we saw good uniformity across from package to package, as well as around the circumference, if you will, of the package. So
Excellent, excellent. And that's all you can ask for, right? In terms of making a good package, if you get consistency across all of them and consistency within one, because sometimes you can get a little variability around, different sides of the package. But if you were able to get pretty much consistent numbers around, I think that's excellent.
yes.
Well, perfect. Mark, thank you for your comments and your feedback on this, and keep up that good work that you're doing in the lab. I'm trying to understand what's going on with Tyvek and all the things you do for us with Tyvek.
Great. Thank you for having me, Jose. Appreciate it.
Perfect. All right. Thank you, Mark. And so just like to first close, and then, or actually, let me bring back Doug. Doug, you still there?
I am back.
Perfect. Thank you, sir. And listen, this has been a great little chat, and really appreciate all the work that you've done, and your explanation on the cohesive technology. And I'm sure whoever's watching this can contact you directly or contact PAXXUS if they want further information on your cohesive system that you're using for this. And I just welcome whoever's viewing this to go ahead and contact directly PAXXUS on any of this. And did you want to say anything about that?
I appreciate that. Yeah, we welcome the opportunity to work on any applications with uncoated Tyvek. I think we have a real interesting product here.
Perfect. Well, thank you, Doug.
All right, thank you.
So in closing, thank you all for listening to this little webcast. Again, this is kind of a little bit of an extension to the science of sealing, or the physics behind sealing. We talked extensively about that variability that can occur, and I thought that when we came across this cohesive system that PAXXUS has, and there's other folks out there that have cohesive systems as well, and we can have them on future seminars if they're interested in talking about their technology. But I think overall, what we want to kind of stress is that if you're really looking for minimizing fiber tear, there's only two ways to go. It's either you put an adhesive on, a coating on the Tyvek, or you use this cohesive system. And adhesives have been around a long time, and so maybe this is time for a new cohesive system. And remember, with a cohesive system, you're just sealing around the edge of the material, and the rest of it is not, it's clean. It's just going to be film. So for those super clean applications, maybe this cohesive system makes sense, right? The other thing, again, is that consistency of peel strength, right? We talked about in the science of sealing how there can be variability because of the deformation that's occurring on the film side of things, right? So if you really need to lock in on something, and it sounds like this material has 1.5 pounds, but again, different cohesive systems, it's great that you can then have a good consistent peel, not only from package to package, but a consistent peel all the way around, right? So that's something I think that's important and needed out there. I think the transfer of color is kind of a neat added effect that these folks at PAXXUS are doing, because again, the nurse or the doctor, whoever's opening it, being able to assure that seal is good and consistent. This could be another way to kind of do that. So Anyway, in closing, please thank you for taking the time to watch this this little conversation here in video. Today we've got to do a little things more virtually, so hopefully this was helpful. If you have any questions or any concerns, please feel free to get a hold of me or talk to us, any of the MDM specialists here at DuPont. And if you need further information on the exact material that PAXXUS is using, feel free to contact them directly. And so, you know, we're going to try to continue to bring some of these kind of informational things on some new technologies maybe that are coming out. I promise we will do another Science of Sealing for those of you who were not able to attend the couple seminars we did last year. We'll do another one this year, or even if you did, just come on in and join us again, because maybe you could pick up a new pointer or two in terms of how that works. So on behalf of DuPont and myself, thank you for attending today's little informational seminar here, and we hope to see you out there soon once we get to be able to travel. So thank you very much and have a wonderful day.